is we're going to talk about absolute values in the context of equations. And then towards the end of class, we'll get to the inequality part. Okay, so the simplest equation you can have with an absolute value is just the absolute value of x equals 3. All right, so we don't really need to do any math with this. We can just figure out what the solution is. The solution is that x can be 3 or x is negative 3. All right, so what the absolute value does is that if x is less than 3, then, or if x is less than 0, it gives you the positive version of that number. Okay, so let's go up one step in terms of complexity. Let's solve x plus 3 equals 5. So there's two things we have to worry about. If x plus 3 is less than 0, then we know that the absolute value has changed the sign of that thing. And that's why I put that first line. The absolute value of x plus 3 equals negative x plus 3. It doesn't mean that anything other than that the absolute value changes the sign. So if for some reason x plus 3 equals something like negative 10, then negative 10 will give us 10. And so that's what that does. If it's greater than 0, of course, it leaves it unchanged. So to solve this, we say, all right, we have x plus 3 equals 5 or minus x plus 3 equals 5. And so when we solve those, we get the first one on the left, the x plus 3 equals 5, subtract 3 from both sides, and we get x equals 2. And so let's just go ahead and go up to that original problem of solving the absolute value of x plus 3. If we add 2 to 3, we get 5. The absolute value of 5 is 5. So that works. On the second one here, we have the, let's see here if I can point to it. Right here. The absolute value will change the sign of this thing if x plus 3 is less than 0. So then if we multiply both sides by negative 1, you get this expression here. X plus 3 equals negative 5. And so when we solve that, we're going to subtract 3 from both sides, and we get x equals negative 8. So let's check that. If we have negative 8 plus 3 is negative 5, and then the absolute value of 5 is 5. Now, usually you don't write that first step. Usually you write the x plus 3 equals negative 5. So mechanically what happens is you start out writing just the positive version of it, so you just remove the absolute value sign and you get the x plus 3 equals 5, and then you write the counter to that, which is x plus 3 equals negative 5. And that's probably what the rule that you've learned in high school algebra. But where it comes from is that the absolute value is changing the value of the expression x plus 3, and then we multiply by negative 1. Now this kind of thing is unimportant really in terms of an equation, but when we get to an inequality, it's going to cause us to do something because we're multiplying both sides by negative 1. Did you have a question?
I just was wondering why you didn't distribute the negative 1 to the x plus 3, but is that just a rule that you don't do that?
You can, and it will still solve, but then you have negative x is what you've solved for, and then you have to multiply by negative 1 again. Okay. So it was just easier to do it this way. Okay. It's a different path that'll take you to the same place. Okay, so you try this one based on what we've done. Come up with an answer, okay? So hopefully this is what you did. You wrote the equations x plus 1 equals 6 or x plus 1 equals negative 6, and so you got x equals 5 or x equals negative 7. Now I checked the other ones out loud, and here I'm doing it in writing. And I really strongly suggest that you always check these, all right? Because we're going to find that the solution that you get, even when you do the problem perfectly, isn't really a solution at all. That for some reason it doesn't work, and we'll see some examples when it doesn't work. Okay, here's another one, a little bit more complicated. You can try that one again. Okay, it looks like a few of you put your pencils down, so we'll go ahead and do this one. So we write the two equations, and so I have 7a plus 6 over 4 equals 2, or 7a plus 6 over 4 equals negative 2. Now I put the word or in there because you might say, well, the solutions to this are x equals this and x equals that. But from a really persnickety mathematical standpoint, x is one value or the other, right? It can't be two values at once. So we write this as an or because x won't be both values at the same time. And so solving these, we get to the first one is a equals 2/7. And then the next one is we come out with a equals negative 2. Okay, so it's a matter of multiplying both sides by 4 first. And then we subtract 6 from both sides, and then we get two different answers there. And if I check these, and I'll just do it in line, so I plug in one of the values, and I get 2, and I plug in the other value, and lo and behold, I get 2 again. See, in the first one, it's just 7 times 2 over 7 is going to be 2 plus 6 over 4, and then you have 8 over 4 is 2. The second one, you have negative, that 7 times negative 2 will give you a negative 14, and then you add 6 and divide by 4, and you get negative 8/4, which is negative 2. Absolute value of that then is 2. So it works, both of them. Okay, and then this one, try this. Okay, let's see. So we set up two equations. We solve these. But now we're going to check. Okay, and what happens is it doesn't work. So what happened was the first two equations I established with the negative 5 and the 5. That was pretty mechanical. I solved all that, and I get x equals negative 1 and x equals 7/3. And then you plug those in, and so you have 3 times negative 1 or minus 2 is going to be negative 3 minus 2 is negative 5. Take the absolute value of 5, and you get 5, which doesn't equal negative 5. The same thing on the next one, where the whole thing equals 5, but that's not what we're looking for. So note that whenever you have an absolute value, you end up with a number that's greater than or equal to 0. And what we have there, the absolute value of a equals negative 5, has no solution. And so if you recognize this from the beginning, if you look at the problem as the absolute value of 3x minus 2 equals negative 5, you can stop right there and say there is no solution because that absolute value cannot be negative. All right, so that's a perfectly complete and sound solution, and it is the correct solution, that there is no, or that's the correct answer, I should say, because there is no solution. All right, so there's an illustration of why you should be checking, because sometimes it's not as clear that you will see that that equals a negative number. Maybe you have an expression that doesn't immediately evaluate to something that's negative. Or if you're just in the rush of things, that you mechanically do it and fail to look at its meaning. So it's really important always to check. Yes?
So when do you put the or? Why don't you do that on the first one? The very first one that you tried?
I've always put or between the two equations. You mean on another chart or on this one?
Oh, so do you okay, so do you always put or when you're looking for like an absolute value?
Well, with an equality, that's correct, because with an equality, you're going to have a particular value of x that's going to be your solution. But with the absolute value, you could have more than one solution. And so x can only be one value, and so in the case of the first one, x is either 5 or -7. It can't be both 5 and -7, right? There's no and to that. X is only one. So when you have the absolute value with an equality, it's always or. Now, in the conversational sense, we'll use and, saying these are both your solutions, but when you really think about it, it has to be or, because it can't be both. Okay, so let's talk about a general strategy for solving absolute values. Let's say we have this one here, where we have more than just an absolute value equals something else. Here we have a coefficient in front of the absolute value. We have a -6 on the left side of the equation, and we have a -2 on the right side of the equation. So what we want to do with this to solve this is that we want to isolate the absolute value. Just treat that as an unbreakable unit and have that on one side of your equation. And so I'll do that here by first adding 6 to both sides and then dividing both sides by 2, and so I get this. Now this should look familiar here. Okay, so now this we know how to solve. We make 2 equations out of it, and then we solve each side, and then we check. Okay, so on the first side, on the left side, we subtract 4 from both sides, and then we divide by -3 and we get x equals 2/3. And then on the second one, we do the same steps, but we get a different value. We get x equals 2. So if I put it in to the original equation, I have 2 times the absolute value of 4 minus 3 times 2/3, and so on. And this reduces down to -2. Okay, so the first solution works. And then this next solution, we stick in a 2 where x is, and we find that that indeed does go to -2 again. So you see, because we have other things in this original equation, it's not, the rule isn't just the right side, the right-hand side of the equation can't be negative. It can be negative, but once you get down to the point where you have the absolute value equals a number, that must be positive. The absolute value is always 0 or positive. Now, there's one really big caution, and I see people do this. I see people do this a lot, okay, where they want to somehow take the absolute value of what's inside the absolute value terms individually. So if you have x minus 6, now you can probably come up with some isolated case where this may be true, but in general this isn't true, where you can't take the absolute value of each individual term and add them up. So for example, in this particular one, if x equals 2, then 2 minus 6 equals -4. Absolute value of that is 4. But if I take the absolute values first, what I get is the absolute value of 2 plus 6 equals 8. So clearly they're not the same. So the absolute values, the expressions inside the absolute values have to remain together, And when you separate it out to those two equations where one is the kind of the positive version, one's the negative version, you never do anything to what's inside the absolute value. You just make the two equations and don't solve those things separately. Okay, any questions? But it's a big caution because sooner or later you're tempted to do it. Okay, so we have another case. What happens if we have more than one absolute value? So let's say we have something like absolute value of A equals the absolute value of B. And let's say A and B are just expressions. What are we going to do? Make four versions of this where you have A equals B, or A equals negative B, or negative A equals B, or negative A equals negative B. You find that two of these are exactly the same thing. Like, look at the interior two first. A equals minus B is the same thing as minus B equals, or minus A equals B, right? You multiply both sides by -1, one turns into the other. And the outside one, where you have A equals B, is the same thing as negative B equals negative A. So really all you have to do is still, with two absolute values, have two cases. And so what you do is you just choose one side to make negative. And so when we have an expression like this, the absolute value of x plus 2 equals the absolute value of 3x minus 6, I make two equations. And I want to point something out here before we go on. Notice I put the parentheses around the 3x minus 6. This is crucial that the negative is applied to the whole thing, because remember, the absolute value changes the sign of the whole expression, not just to the individual components. So you put a negative with parentheses. Now you can distribute that negative once you do that, and that's the correct way to do it. So when we solve these, the first side, we get, let me talk about that first side first. Where the first thing that we're doing there is we're adding 6 to both sides, and then we subtract x from both sides, and we get 8 equals 2x. And so x equals 4. Okay, so then on the second side, make sure you distribute that negative sign. And if you're going to make a mistake, if you've mastered this material and you're confident and you're working really, really fast and you're going to make a mistake, this is where it likely is where the mistake happens. Okay, where you have to apply that so you get the negative 3x plus 6. All right? And so we go on from there, and we'll add 3x to both sides, and then we'll subtract 2, and we get x equals 1. And we check it out, and sure enough, we get absolute value of 6 equals absolute value of 6, 3 equals 3, and those are your two solutions. You will not be getting 4 solutions out of this thing because of that earlier reasoning where it's just a matter of which side do you put the negative. Now you could have chosen that second case. Instead of putting the parentheses and the negative in front of the right side, you could do it to the left side as well, but you just have to do it to one of them. You have to say, in the first case, the left case, that's where the signs agree, and then the second one is where the signs disagree. Now, especially on these, you may end up with a solution that doesn't work, and you may end up with one solution instead of 2 solutions. So you have all 3 possibilities: no solution, 1 solution, or two solutions. All right, are we good? Okay, so go ahead and try this one then. So let's look at this. We make the equations where I'm going to take the right-hand side, put parentheses around it, make it negative for the second part of that. The first one, I just use the equation with removing the absolute values. And so I'm going to add 3x to both sides. You got x equals 0. And then do something similar to the right, where the first thing I do is distribute that negative. So I have a negative 1 plus 3x. And then I subtract 2x from both sides. And so I get 2 equals x. And so I'm going to check both solutions. And sure enough, we get a good solution for both. So x equals 0 is a perfectly good solution, right? It's tempting sometimes when you have a 0 to think, is that really a solution? It's only when you have a contradiction, like 0 equals 2, that's not a solution. But 0 equals x is a perfectly good one. Okay, caution again, make sure you put parentheses around the whole expression. Yes?
So when you do the check at the table, why you don't use the minus like on the absolute 1 minus 3?
I'm substituting 0 in where x goes, right? And so I have 2 times 0 plus 1. That's the left side. The right side, it's 1 minus 3 times 0.
But you don't use the minus like...
Yeah, the minus 3 times 0 is 0, so I have 1 minus 0. Does that work?
Yeah.
Okay. And then you can see what happens to the other side. Okay, another one. Okay, so let's see where you went here. Anybody get a solution that they want to offer? Yes.
X equals negative 4?
X equals negative 4?
Yeah.
Okay, so if we, let's see if that's what I get, but negative 4, you got one solution then. So what happened with the other one?
There was a contradiction.
Okay, there was a contradiction, good, because that is the case. So set up the two equations. The first side, when you subtract 2x from both sides, you get 7 equals 9, which is a contradiction. That's what you got, right? Yeah, okay, then in the second one, then, you have 2x plus 7, and you distribute that negative, and so we get x equals negative 4, that's what you got. And so then we'll check that. And so you plug in the negative 4 to both sides and simplify it, and so we get down to 1 equals 1, which is true, and so we get one solution only. Now, it's important when you're checking your solution, and this goes in general whenever you're checking your solution, go to the original equation, okay? Don't go to an equation that maybe has 1 or 2 simplifications in it, because either your error or something may have crept in that first or second step. Perhaps there was something like, remember when we had no solution where that absolute value equals negative 5, if you just put in the values that you got for those things with the two equations that you got separated by or, you would have found that those equations were true. It's just that the first equation didn't work, not the subsequent ones. So always stick things back into the original equation when you're checking equations. Okay, so now we're going to move on, and we're going to talk about absolute values and inequalities. And so what I want to do is go back to when we were originally talking about absolute values and the differences between two numbers in an absolute value. I want to think of that in terms of being the distance from A to B on a number line. I'm not talking about a two-dimensional space. I'm talking about a single dimension, length only, that if I take the difference between two numbers and take the absolute value, I'm getting the difference, I'm getting the distance between those two. Right? So if A is 6 and B is 4, the distance is 2. If I start at 4, if A is 4 and B is 6, I get 4 minus 6 equals negative 2. Absolute value is 2, so I still have a positive value for the distance. So when we're dealing with inequalities, we want to kind of look at this in the context of distance. But let's kind of revisit the equality thing first. Here's one of the simple ones that we started out with. If I put this on a number line, what I'm going to have is my two solutions, 3 and 9, are 3 away from 6. Okay, so look at that expression in the absolute values, the x minus 6. So we're talking about the distance of x and between x and 6, right? And so what we're saying with that equality is that that distance has to be 3. And so what is 3 away from 6? Well, 9 is 3 away from 6, and 3 is 3 away from 6. So when we're using inequalities, if we think in terms of this as being the distance, it's going to give us a clue as to what of how to treat these things, whether we're going to use an and or an or. Okay, but is everybody comfortable with this concept of looking at these absolute value expressions as distances equaling a certain value? So let's put an inequality in there. So if we say the distance from x to 6 is more than 3, okay, I put that on my number line again, and here, if that distance is more than 3, actually I'm running ahead of myself here a little bit. If that distance is more than 3, that means it has to either be 2, 1, 0, or any number, you know, to the left, or it can be 10, 11, 12, any number to the right. And so this is an or situation, right, where x is either on one side of, it's in one interval, or it's in the other. And so when we solve this, let me just back up a little bit here. If I do this thing of saying, okay, the absolute value changes the sign when I have a negative number, I have this negative x minus 6 is greater than 3, right? So all I've done is I've changed the sign of that expression, kept it greater than 3. And if I multiply through by negative 1, what happens there is I have to change that sign. And so when we're solving these and making the two equations, you can go right away to that second equation. On the right-hand side, make that negative, but remember to turn around the inequality. So instead of being greater than 3, you have to be less than negative 3. And then we solve it in the conventional way that we've done inequalities before. And so then we check. Now there's a couple ways to check this, and here I'm checking it with representative numbers that are in the intervals of the solution. So what I mean by that is, okay, if I put in a 9, well it should never equal 9, right? It can be up to 9, it can be you know, some value like 9.1 or something like that. But let's just take an easy number to check. So 10 is clearly greater than 9. So let's say if x equals 10, I put that in my original equation, and I get 4 is greater than 3. That's true. So I know that I'm fine. Now what it's not telling me is did I calculate the 9 right, but what it's telling me is that that part of the interval is right. Same thing on the right side. If I put in a 2, which is less than 3, I'm going to ultimately get 4 is greater than 3. So my solutions are on the well, now I'm talking about left and right that are mixed. The x is greater than 9 gives me the interval that's on the right on the number line, and the x is less than 3 gives me the interval that's on the left on the number line. So go back to the original equation where you have this greater than 3. So if you have an absolute value that's greater than 3, that's saying the distance is more, and so it has to be an or statement, and that you get these inequalities that have intervals that are away from this central number, this 6. Okay, so it's a little bit like saying you have to be more than 10 feet away from me. That means you're going to be outside of the classroom either this direction or that direction. And it's an or. Either of them work. So now let's look at the other one. where we have a less than. Okay, so here we have the distance from x to 6 is less than 3 now. Okay, so what I'm saying is that an equivalent thing would be the distance from me, right or left, is less than a certain value. So now I have to be within an interval, right? So if I were to graph this, I would expect the graph to look something like this, where this is within 3. So it's not sufficient to have one condition, it has to meet both conditions, right? It has to be greater than -3, and it also has to be less than 9. So when we solve this, we actually make this into two equations that is an and. Now we still do the same thing with that right part, where we're going to turn around the inequality sign, and we're going to make that a -3. And remember, the reason why we did that is because we originally had the negative around parentheses on the left side, multiplied through by -1. That changes the direction of the inequality and gives us a -3. So when we solve this, we get this interval. Now, before I start checking, x has to be less than 9 and it has to be greater than 3. It's certainly not an or, because if that was an or, then 10 would be a solution, right? Because 10 is greater than 3. But it can't be. It also has to be less than 9. So we can rewrite these ands as 3 is less than x, which is less than 9. And so if we check it, we know that 5 is somewhere in between 3 and 9. And so if we stick a 5 in there, we simplify this thing around and we get 5 minus 6 is less than 3. The absolute value of 5 minus 6. Absolute value of 1 is, of -1 is 1, which is less than 3. So we know we're good with that solution. And then we can solve the equality if you substitute, or if you imagine that you put an equality in there, then you can, if you stick in either a 3 or a 9, then you should get the boundary. Then you should get exactly the value rather than an inequality. Okay, so here's one for you. Now, I didn't make any comment about the greater than or equal to or less than or equal to, but the rules are the same. It's still an or when it's greater than or equal to. It's an and when it's less than or equal to. So think of and as being within, or is, of course, greater than. So we'll look at this solution, and we make up two equations. It's an or because it's greater than. And so we come out with x is greater than 2. Now that's a little different than I saw on some of yours. I think I saw a 2 and a -2. Did I make any mistake, or is that what you got?
I got 2.
You got 2?
So it's two.
Okay, so if we check it, I guess that's the proof positive. Here we can just stick in the number, and lo and behold, we do get 11 equals 11. Okay, and so here's another one to try.
What were you saying about the and or with the greater than?
Yeah.
Can you repeat that?
So in this case, with the greater than, you want the distance between those two numbers to be greater than something, so it's an or, because it can be greater on one side or the other.
Okay.
If it's less than, you want it within, and so both criteria have to apply, so it's an and there.
Okay.
Yes?
Why did you decide to change the sign on the right side?
On which one now?
The right side, you decided to change the sign.
The 7x minus 3 is less than or equal to -11. That's what we do. We change the sign and we turn around the inequality. Okay, so So the basic strategy that we have with this is isolate the absolute value. And so the first thing that we're going to do is multiply both sides by 4. Now in this case, it probably wouldn't hurt if we didn't do that first, if we made the two equations. But if that were a -4, and we'd multiply both sides, then we would change the direction of the absolute value sign, so, or of the inequality. So it's important to isolate that, that absolute value. And so I get y minus 16, the absolute value of that is less than 120. So it's less than, so I'm going to make two equations that, that both must be true, so I put an and there. The first one I get is y is less than 136, and then the second one I get is y is greater than 104. And so I can rewrite that to minus 104 is less than y is less than 136. Check both values on it, and I get to 30 on both of them. So my inequality numbers are right. And so the first one, when I actually substitute 136 and negative 104 in there, is I'm saying, okay, if this was an equality, did I get my numbers right? Because the numbers should go all the way through. But then did I get my interval right? And I noticed that 0 is in between negative 104 and 136. So I can test that as well, and I come out with 4 is what that expression equals, which is less than 30, so that's true. So I'm confident that the boundaries of my interval are correct, and that the direction of the interval that I'm between those numbers, not outside of those numbers, that is correct as well.